Okay, so now we're going to look at how to factor some trig expressions. Remember, factoring means you just want to take the expression back to what it would have been before it was multiplied out. Okay, so the first one that we have here is secant squared x minus 1. All right, sometimes the easiest way to see how to factor it is to rewrite your problem with your trig function being a variable. So if I replace secant squared x with, we'll just call that x squared minus 1. If you look at this, you may immediately know how to factor that. If you know how to factor that, then you can apply that same principle to your trig. Okay, so most of you should know that this is a difference of squares, which difference means it's subtraction, and squares means the two things that you're subtracting have perfect square roots. When you're factoring a difference of squares, you put the square root of the first term here and here, which in this case would be x, because x times x is x squared. And you put the square root of the second term here and here. The square root of 1 is 1, so 1, 1. And then you make a positive and a negative, and then if you were to FOIL that back out, you're going to get what you initially started with. So that's how an expression like this would factor. That means that's how this one's going to factor as well. Okay, so we're going to break this down into parentheses. The square root of secant squared is just secant, so we're going to put a secant x here and a secant x here. And then the square root of 1 is 1, so we're going to put a 1 here and a 1 here. And again, one's positive, one's negative, and there it is factored. If you factor and you look at these factors and it looks like they'll simplify further using one of your trig identities, then you want to go ahead and simplify further. But in this case, neither one of these are a trig identity. Now be careful because they're close. If you look down here at this Pythagorean one, we do have a secant squared minus 1 that equals tangent squared. But it's got to have those squares in it. And see, right here we have secant minus 1, but not secant squared minus 1. So that is not an identity, so that's our final factored form. Okay, let's look at the next one. We have 4 tangent squared x plus tangent x minus 3. Okay, let's treat this as a quadratic expression with variables, okay? So I'm going to let my tangents just be x's. So this would be 4x squared plus x minus 3. Okay, so when you factor a quadratic expression, just like up here, you're going to break it down into its two sets of parentheses. Okay, now these are not perfect squares like this up here, so you're going to have to just try some things out. Here and here, we need to put factors that give us 4x squared. So you have two options. You can use 2x and 2x, or 4x and 1x. Okay, so I'm just going to try 4x and 1x, okay? All right, and then here and here, we need to put factors of negative 3. And whatever we choose to put here and here, we have to make sure that when we do outer times outer and inner times inner, that we end up getting 1x, which is that middle term right there. See, what we're doing is we're doing the FOIL method in reverse. Rather than multiplying the two parentheses out, we're trying to go back to what the two parentheses originally were. So I know that to get a negative 3, I've got two options. I've got 1 and negative 3, or I've got negative 1 and positive 3. So you kind of have to think about where you need to put those and which signs need to be negative so that I end up with that positive 1x. Okay, so I think if we put the positive 1 here and a negative 3 there, so I'm using this one, that I'll end up with a positive x when I do my outer and inner, because I have a 4x this way and I have a negative 3x this way, so that gives me 1x. That's what I want. So the way that this one factored is exactly how this one's going to factor, except instead of x's, we want to go back and put our tangents back in there now. So your first set of parentheses would be 4 tangent x minus 3. And then your second set of parentheses is going to be tangent x plus 1. and neither one of those are an identity, so we're going to leave it like it is. All right, let's look at example 3. We have cosecant squared x minus cotangent x minus 3. Okay, if we try to write this as a quadratic expression, we run into a little bit of an issue because we have two different trig functions. Okay, see, so up here we had both tangents, so we could let both of those be x's. If we were to write this, let's say we let our cosecant be an x, that would be x squared. We would have to let our cotangent be a different variable, so maybe like a y, and then a minus 3. Okay, there's no way to factor this with two different variables. So what we need to do is try to use some of our trig identities to see if we can change one of these two into the other. Okay, and if I look over here at my cosecant squared Pythagorean identity, cosecant squared is the same as 1 plus cotangent squared. So I can replace this cosecant squared with 1 plus cotangent squared, and then my problem will have all cotangents in it, and then I'll be able to factor it. So that's what I want to do. I'm going to put 1 plus cotangent squared in place of this cosecant squared here. Then I'm leaving the rest of the expression the same. So all I did was replace that with a Pythagorean identity. And now I just want to get it in order and put it in standard form. This 1 doesn't need to be in the front. It needs to go back here with this negative 3. So if we combine positive 1 and negative 3, we get a negative 2. Okay, so there it is in standard form. So let's think about how we would factor this. Now I've changed everything to the same variable. Okay, same trig function. So you can treat it as an x or a y or whatever. But basically I don't have this anymore. I have x squared minus x minus 2. So if I was going to factor that, I know that for x squared I need an x and an x. And for negative 2, I either need a 1 and a negative 2, or I need a negative 1 and a positive 2. So if you think about the fact that your outer and your inner have to add up to be a negative 1x, that tells me that this one right here is probably the one I need. So I'll put a negative 2 and a positive 1, and then double check your outer and your inner and make sure they give you this, and they do. So this is how I want to factor this expression. So now I'm going to bring this back over, but I'm going to change my x's to cotans. And that's your factored expression.